Hello everyone, today I will start talking about the polymer chemistry. In specific, we will talk in this video about the different types of polymers. So the word polymer itself means the long chain. This long chain molecules that forms this polymer usually distinguished by their high molecular mass that ranges between thousands or millions of grams. They are made out of smaller monomers which are joined together. So in here you could see that I have here those monomers which are joined together to form this longer chain. There are two types of polymers, either natural occurring polymers, including protein, nucleic acids, cellulose, and rubber. Synthetic polymers usually made out of organic compounds such as nylon, dacron, or different type of organic synthetic polymers. Now, the synthetic organic polymers we can prepare them using addition reactions or condensation reactions. I will talk briefly today about addition reactions. In the next videos, we will talk about each reaction in details. In here, you could see that in addition reaction, unsaturated compounds that contain double or triple bonds, we will break this bond and form saturated longer chain, where we will add those monomers together. Similar to that, the polyethylene. The polyethylene is made out of ethylene monomers that are joined together due to the breaking of the bond between the two ethylene carbon atoms. The initiation reaction, the first step of the addition reaction is the initiation reaction. In here you could see that I have initiator. This initiator produces two radicals, and these two radicals will further attack the double bond. I have different types of initiators that we can use, either azo compounds, inorganic peroxides, or organic peroxides. The radicals that formed from the previous step start attacking a double bond of the ethylene to form to bind to my ethylene by breaking this double bond and forming this ethylene radical. This ethylene radical would go through the propagation reaction, where another ethylene molecule would be added to this radical, and the longer radical is formed. Termination reaction happens due to the using up of my initiator or my ethylene in that case, or my reactants, and in that step what happens is two chains with just two radical chains will meet up together to form a longer chain, and the termination happens. Now, the homopolymers, this is another way of classifying polymers. We can classify them according to the different types of monomers used in the polymerization. If I have the same type of monomers coming together, this means I have what we call homopolymers. If we have different types of monomers coming together, we will name my polymer copolymer. Now, for the homopolymer, there are two. Here I have two examples, the Teflon and the PVC. You could see that the repeating units are those repeating units, and it can be synthesized using the radical mechanism. Now, for the homopolymer, we can subclassify the homopolymers into systematic polymers. Those systematic polymers, if I have here R group, you could see that it is disposed randomly over my chain. This is when I have a tactic polymer. This random addition of these monomers together will lead to the disposed position of the R over my chain. This will give amorphous and relatively weak longer chain. And if I have the R group instead organized in my one side of in a systematic way on my chain, in here I have the R group on one side, the same side of my carbon atoms. This is where I will have the isotactic structure. The isotactic structure is a much stronger chain. The third type is asymmetric polymers, but with a repeating pattern. So in here you could see see that the R group is alternating from left to right over my chain from left to right. This will give it like a pattern. This pattern will give me a high melting and a high melting point polymers with a greater crystallinity comparing to the tactic, which is randomly organized, or the isotactic polymers. Those are what we call them the cyanotactic polymers. So we usually, when we try to prepare polymers, we use the Natta-Ziegler catalysts. Those catalysts are used to prepare a certain or designed polymers that suit any purposes. So in here you could see that there is two types of this Natta-Ziegler catalyst, which is the triethylene aluminum, and this triethylene ammonium also come with the titanium trichloride to give me a specific type of isomers. This is how we can promote a certain type of isomers and obtain designed polymers. Rubber, which is a natural occurring polymer, is formed from radical addition usually, and it's a natural occurring polymer with a cis isoprene, which is the monomer of the isoprene. The stretched rubber has no regular X-ray diffraction, and therefore it's amorphous. So you could see that isoprene, when it comes together, it forms this polyisoprene, and this polyisoprene is either cis or trans. The cis isoprene, which is a natural rubber, is amorphous, and it can be stretched and possess a fair amount of crystallinity. The natural occurring rubber have a problem when it is elongated for a long time. It loses its elasticity due to the extended rubber chain slipping over each other. This is why we use what we call vulcanization. Vulcanization is the addition of sulfur and a catalyst, which is the zinc oxide, during the polymerization. This will prevent the chains from by creating a link to the sulfur in my chains. This will prevent my chains from slipping over each other. Now, you will hear this word during the study of polymers, the neoprenes. The neoprenes are the synthetic rubbers or the synthetic monomers that we use to form synthetic rubber. Similar to that, example for that, the chloroprene. The chloroprene is used to form the polychloroprene, which is a synthetic rubber, have a higher crystallinity and elasticity more than the natural rubber. By that, we came to the end of this part of introduction to polymers. Until next part, thank you and goodbye.